just not brought over correctly. They should be, the first one should be what, sine squared theta,
The
Cos
theta,
phi
the
of
phi.
cosine phi, and then dp.
Yeah, sine squared theta, yeah.
Should be squared, and then it needs a cosine phi as well.
Sine of, sine squared theta, cosine of phi, d theta, d phi, all right?
And then next one is
The next
sine
one
squared.
is r squared sine squared,
Sine, that's right.
sine of phi.
And then the last one was right.
Okay, all right. Now, x, y is that. So ex, ey is that. So what do you have here? You have sine dxy. That's dxy. So sine squared sine phi cos phi d phi. Wait, let me make sure. So when we integrate with respect to, okay, for this one, when I substitute in there, the little sine phi to phi, txy is xy is that. So sine phi cos phi sine phi, yeah, sine squared. Yeah, okay, yeah, I think all right. Now let's look at this one, all right? So if you replace the xy, which is epsilon naught times xy, what do you get for txy? Txy is epsilon naught e, txy epsilon naught ex, ey. Now ex, ey is this, right? So you have sine phi cos phi, right? And from this you have sine phi, so that's gonna be sine squared phi cos phi d phi, right? So if this is, let me write it down explicitly just to show you it is going to be 0. If you can see that, I don't have to do it, but okay, so the integral of dxy r squared sine squared of theta sine of phi d theta d phi. Just if I write the integration for that, that's going to be the integral from 0 to pi over 2, from 0 to 2 pi, from 0 to 2 pi, from 0 to pi over 2. Now in place of txy, if I write that, which is going to be epsilon naught, ex ey, which is that. So if I write that one, that's going to be q over 4 pi epsilon naught 1 over r squared, the whole squared, times sine squared of theta cos squared of phi, right? Oh, no, I wrote the wrong one. It should be this one, right? Are you following me? It's kind of nasty algebra, so sine. So this is what I'm going to put. That's the sine squared of theta, sine of phi, cosine of phi, multiplied by what?
Sine squared.
So that would make this one square. D theta, D phi.
Isn't
Huh?
the sine squared theta should be sine to the fourth? Shouldn't go to the fourth?
Yes, okay. Sine squared theta. Yes, that is 4. Good. Well, but it doesn't matter because it's going to be there. So that's the whole point that I'm trying to show you. Because when you integrate first with respect to phi, what do you get? You get sine squared, sine cubed phi over 3, right? When you sine squared phi, cos phi, d phi, it gives you sine cubed phi over 3. When you evaluate that at 0 and 2 pi, what do you get? 0. You see that? So this is going to be 0. So what can you conclude for this one also? That's going to be 0. So we can say that this is going to be 0 and this is going to be 0. All right? So based on a similar argument, what can you say about for the y component? So let me just write it down here. So what you would end up for t dotted dA x component, what would survive for this integral? For the integral, what is going to survive is just only this term, right? So I will just write that one. So that's going to be the integral from 0 to pi over 2, from 0 to 2 pi of t times dxx r squared sine of theta cosine of phi d theta d phi. Now who can tell me what is gonna be the survival term after we take this with that? Yes. Okay. So we are in the same page. All right, I don't want to read this part. Okay, so for following a similar procedure, we can show that T, the thrust tensor dotted with dA, y component is going to be after you did the integration, of course. After you did the integration, what you would find is going to be the integral from 0 to pi over 2, from 0 to 2 pi of which term? Tyy times the y component of the area vector, which is going to be this one. So you have Tyy times r squared times sine of phi d theta